increasing function. So we've talked about the fact that the derivative tells us about the gradient of the function. Okay. And if the value of a function increases as x increases, it means that the graph is said to be increasing. That makes sense. If the value of y essentially goes up as x goes up, then we're going to be plotting points that go in that direction. Okay, so it's going to be increasing. If the value of a function decreases as x increases, the graph is said to be decreasing. Okay, makes sense. If the derivative is greater than 0, okay, it means that there's a positive gradient. We know that positive gradients are uphill direction, yes? Well, that tells us, therefore, that the gradient, then the function would be increasing. So if the gradient is greater than 0, then we know that y is increasing. If the gradient is less than 0, we know that it's decreasing. So here's a little diagram just to make that clear. So we know this graph is going up, you can see it's going up, but equally it means that the gradient must be a positive number. Okay, because it's an uphill gradient. We can see that this graph gradient's going down, or the graph is decreasing because it's downward direction. But we can also see that this would be a negative gradient. Similarly in this part. Yes, you're happy with that? Yes. So write down the intervals on which the function is increasing or decreasing. So when they talk about intervals, they want to know which x values are we talking about. Okay? So where is this function here increasing? Increasing. What did you say, Cameron? These are increasing?
No, decreasing. Because it has negative gradient. 0.5. Increasing.
Well, so hang on, so Cameron, do we see that that would be a negative gradient? So the graph, remember we always read things from left to right? So it would be, this graph here is decreasing, it's going down. Yes? Sure? So it's increasing in this portion here, yes? So, Olivia, you said 0.5, you're trying to look for a value here. I'm hoping you appreciate this is a quadratic graph. It's going through the point 0, 0. It's increasing for values of x greater than 0.
Oh, that makes sense.
Okay? And it's decreasing for values of x that are less than 0. Yeah? Notice I haven't mentioned the or equal to because in some situations the graphs are stationary. I think we go to stationary. Alright, B. Where is B increasing? Is it not increasing the whole time? Yeah? So this is an exponential graph. Okay? So whilst we can't really see what's going on down here, we're assuming it's going on and on forever. So this would be increasing for all real values. Which obviously means it's not decreasing. Remember this, how we write this? The member of all real numbers. If you want to write in words, you can write just for all real values. And then this function here, increasing. So hopefully you can see it's increasing in this portion and this portion. Yeah, you'll have with that? The two black bits, it's increasing. So that's x is less than 0 and x is greater than which value? 2. Lovely. And then it's decreasing in this bit. Whoa! Bless you. So it's decreasing between 0 and 2. Remember, for a range, we write it with our inequalities pointing left, smallest number on the left, biggest number on the right. So, stationary points. If f dash x, remember f dash x is another way of talking about the gradient. So if then f dash x is equal to 0, then the function is neither increasing nor decreasing. Okay? It means that the tangent is horizontal and that it is a stationary value. So we would call it a stationary value. Remember, when we talk about this tangent, that's how we're finding the gradient or the derivative. Okay? So if we were going back into basic skills, so if we didn't know all about differentiation and we wanted to find the gradient of this graph at this point, remember we would have drawn a tangent to it and find the rise over the run. So that's why we're mentioning the phrase tangent there. Okay. So the coordinates of the stationary value would therefore be a, f, a. So here, at this point here, the derivative is equal to 0. At this point here, the derivative is equal to 0. And at this point here, the derivative is equal to 0. Okay? This is where it's changing from a increasing, so it goes increasing, stationary, increasing. Okay? Now, these are all known as stationary points. So the key thing to know here is that stationary values occur when the derivative is equal to 0. This relates to optimization. Okay, optimization is what we just talked about, I just recapped, remember? Where the maximum or minimum things occur when the derivative is 0. This thing. So stationary points. These points occur when the derivative of the function is equal to 0. There are 3 types. There are maximums, minimums, and points of inflection. So they do this or this. Okay, so this would be the maximum stationary point, the minimum stationary point, and these will be points of inflection. So what may happen in a question is that they will ask you to find the stationary points. So in other words, to do that, we would find the derivative, an expression for the derivative. We would put that equal to 0, and we would then solve it. Okay. Now, if it was a quadratic, the derivative will be a straight line. So that should be straightforward, and you'll just have one solution. If the function was a cubic, when you differentiate it, it becomes a quadratic. Okay, because remember, the power always goes down by 1. So if you have a quadratic, remember you're going to have 2 solutions. How do we solve quadratics? Well, we either factorize or we use our calculators. So depending on which paper it is, you will obviously be able to factorize it easily if it's on paper 1, or otherwise use your calculator on paper 2. If it's to the power 4, it would go down to be a power 3. Now, we haven't learned how to solve those, but you can use your calculator. So remember, when we use the calculator to solve a quadratic, do you remember there was that section where it says order? So or the power, highest power of 2, highest power, and we've always had it on 2 flashing. I'm getting a few reflections. Pardon?
On the calculator?
On the calculator, yes. Or we would obviously change that to the power of 3, yeah, okay? So we would change that to be a cubic, or whatever we would need to solve. So if it's anything harder than a quadratic, it would be on the calculator paper and you'd be able to solve it that way. Right? I'm just giving you a heads up on that, not to panic. So that's finding where they are. So we're going to have 1, 2, 3, however many values of x where those stationary points are. But they also may ask you to find the nature of the point. Now what that means is it a maximum point, is it a minimum point, or is it a point of inflection? If it's on the calc paper, you can always sketch the function and have a look at it. And you can draw a sketch of what you can see on your calculator screen, and you can identify it that way. Otherwise, you have to do something more specific, and we'll talk about this. Now,